Welcome to part 1 of Astronomy Notes, probably around 6 parts in all, 2 tests. So let's go ahead and get started. The first thing that we look at when we look at astronomy notes, in the first definition we got to look at is what is astronomy. And astronomy is the scientific study of extraterrestrial objects and phenomenons. So, the first thing we have to do is we have to look at this word right there. Extraterrestrial. What does that mean? Extraterrestrial. First off, you got to break down the word. You have to separate the two. Extra, then there's terrestrial. So we all know what extra means at this point in 6th grade. So now we got to take this word terrestrial. What does that mean? Well, if we take it and look at some of the base words, we see a word in there called terrain. And terrain basically means ground. So when we look at this and we say extra ground, we can also say extra land. So when you say the scientific study of extra land, you're just talking about anything other than our own Earth. And then some people would include Earth as a part of the astronomy. And then we look at phenomenons. Phenomenons are just things that we see out in space that we can't really explain, and we try to. Now, we go down to cosmology. We're going to do a lot with cosmology because in cosmology, this is the study of the origin and structure and the future of the universe. So what are we talking here? We're talking our theories. And that's what we're talking, as I get this spelling right. So we're talking theory. Now, in this theory, we're going to explore many theories that some people don't believe in, some people do. So take each one as you will, and just understand they are theory. They're not disproved, and they're not totally proven, because if they were totally proven, they would be considered law. So, moving on. First thing we got to understand are some of the early astronomers. Some of the very first early astronomers were from the Mesopotamia area, and even leading back to the Mayan civilization, especially if you've ever taken a trip or go down to the Riviera Maya area, and you know that there's there's an entire lost civilization down there. We'll talk about them at a later date, but today we're going to talk about some of the early astronomers. Now, we've already touched base with some of the projects we've done with some of these people, so you probably are very familiar with many of them. So, let's start with the very first guy. In the year 140, Ptolemy, that's Ptolemy, Ptolemy theorized that Earth was the center of the universe. Now, he said Earth was the center of the universe, and that the other planets and the sun revolved around the Earth. Ptolemy took his ideas to the powers at be at the time, which was the Roman Catholic Church, and obviously they enjoyed it. They liked it. They said, yes, we will go with this idea. Now, Ptolemy's idea of a geocentric model, which geo means Earth, he, did have some valid points, and you could go by his model, and you could see some of the things that you would see in the night sky, and he could, according to his model, really show a few of the things that happened on a regular basis. But in 1543, a man by the name of Nicholas Copernicus, he comes along and he theorizes that the sun is the center of the universe, And this starts a whole new thought process, and this is a heliocentric model. And of course, helio stands for the sun. So obviously he thinks the sun is the center. Now he does this by observing and watching things and seeing how the stars, not just the planets, will move, but he noticed that there's other movements as well that kind of give us this thought behind it. But he had no way to really truly prove his own thoughts. But in 1609, a man by the name of Galileo uses a tool known as the telescope to observe objects in space, including craters and mountains on the moon, and seeing sunspots on the sun. Galileo confirms Copernicus's ideas based on the fact that he was looking at Venus and seeing that Venus had many different phases that like the moon. So therefore, the Venus could not be really orbiting around Earth, but it is orbiting around another body, and that body was the sun. Now, of course, Galileo and Copernicus, they were not really thought of very highly by the Roman Catholic Church at the time, so they spent a lot of their time, especially later on in their lives, in a house arrest situation in prison because of their beliefs. It wasn't until 1609 also that another man by the name of Johannes Kepler stated that all the planets revolve around the sun in elliptical orbits. Now, before, everybody said it was in circular orbits. Now we're taking it to another level and we're saying elliptical orbits. Kepler also theorized his laws of planetary motion, and a lot of his laws are still used today. In 1687, Sir Isaac Newton comes along and he shows us all how the objects attract to each other due to gravity. And this is explaining why one object's orbit another. In 1924, another famous man named Edwin Hubble provided that other galaxies exist beyond the Milky Way and that the universe is much, much larger than our own galaxy. And this kind of really opens the doors to how vast and how wide open space really is. Now, at this time, I would say go ahead and go click on the clip or go to the website and play the video about Galileo and how he depicts or figures out that the sun is in the center and not the moon, or not the not the Earth. Now, when we look at the stars, and we need to understand that when we look at space, we're just looking at the light. Now, you need to understand where the light comes from. It comes from the electromagnetic spectrum. Stars give off energy, and all energy, again, this is in your notes, all energy travels in waves. The wavelength reflects the type of energy. The longer the wavelength you see are the radio waves. Then as we get closer to the middle, we start seeing the wavelengths shorten. And so we get some infrared waves. And infrared waves are those heat waves that you will see and register heat by. Now here in the middle is what we would actually see, the visible light. When we look at the night sky, we see visible light, and we see the different things in the night sky. And as we get down here at the bottom, we can see we've got some others as well. Ultraviolet. We go further, we have the X-rays, and then we have the gamma rays. And these are all the different rays and the different energy levels that are given off by the stars. Now, the thing is, we need to understand what we see. Well, we only see the visible light. And in the next slide, we're going to see that when we look up the night sky, we're not going to see that pretty picture that we see on the internet or we see on television when we find all these new images. We only see the visible light. So we have to come up with extra cameras and extra different devices to capture these other energy levels so we can see the full picture. Now looking at these pictures, this middle picture is the composite. This is the picture that is put together by all the other energy levels. And that's something that most people look at and say, oh, well, I can't see that at night. Can I get a telescope that lets me see that? Well, no, you can't. What you have to do is you get an X-ray image of that same exact spot, which would give you a different look. Then you get a radio image, and you get your visible light, and then sometimes you would get some of the other rays added to it. And then what a person would do is they would add different colors to these so you can actually visually see them. And then they compose them one right on top of the other, giving this nice image of what the space that we really don't see, what's really out there. Now, we are going to be talking about the distance in space, and there's a lot of different distances that can get confusing from time to time. So one of the things that we're going to look at is what are the two units of measure that we really use in space. One is light year. Light year is the distance light travels in 1 year, and this is equal to roughly about 6 trillion miles, or 9.46 trillion kilometers. We measure distance outside of our solar system in light years. For example, the second closest star to us is Proxima Centauri, and that is around 4.2 light years away. Now, astronomical units, otherwise listed as AU, this is the distance from Earth to the Sun. We use AUs to measure the distances within our solar system. And again, that distance is somewhere around 93 million miles, or you could say 9.3 times 10 to the 7th miles. Either way, it takes approximately 8 minutes for the sunlight to reach Earth. And again, that leads us to what we talked about in class already, about how the sky at night, you're looking into the past because you're not seeing the stars as they are right now, but you're seeing their starlight as they once were. Now we talk about aphelion and perihelion. In our orbit around the sun, we have an aphelion, which is the distance farthest from the sun, and then we have a perihelion, which is the distance closest to the sun. And in our orbit, actually it's kind of confusing because most people would say that our aphelion, or our farthest spot from the sun, would obviously be winter because it's colder, and our perihelion would be the summer because it's closer. But actuality is that our solar system is, or our orbit is, we are closer to the sun in the wintertime. And the reason being is because if I were to draw the Earth, not a very good Earth there, and let's say this over here is the sun, and the sunlight is shining over at us. And as that sunlight is shining down at us, right now we are tilted in the wintertime. We are tilted because our Earth tilts. We are tilted away from the direct sunlight. So our place here in the northern hemisphere doesn't get the direct sunlight, so therefore it's colder in our wintertime. And even though we are at our perihelion, which is our closest distance from the sun, so in winter we are actually closer to the sun than we are in the summer. And that's a little thing that you can try to always remember, because you can always catch people on that. And a lot of adults sometimes get confused on that too, and they don't realize that yes, we are closer to the sun during winter than we are in the summer months. And that concludes our part 1, and next time we will be talking about the different stars, and we'll be talking about how the different light produces different colors.